Hello and welcome to Mathmaster. In the last class, we have discussed about what is a set and how can we describe it. Okay? So, now we will discuss about what are the different types of set. Okay? Before discussing, let us look at the three examples. Okay? In the first example, there is a set of students. That means in this set, the elements are the students, okay, who have failed in class 11 examination in 2021. Okay, let us analyze this example. First of all, we know that in 2021, this year, the government has promoted all the 11th class students. Okay, that means no student of 11th class have failed. Okay, so if I ask you, then how many students of 11th class have failed in 2021, then the answer is no one. Okay, no one has failed. So if I make a set of these students who have failed in 2021 11th class examination, then there should be no elements. There should be no elements. Okay, now look at the second example. In the second example, the set is of players who have played 2011 World Cup Cricket World Cup final. Okay, as you know that in 2011 India won the Cricket World Cup. Okay, and we also know that in a cricket match there are only 11 players who can play the match. Okay, that means if I make a set of players who have played one particular cricket match, then there will be how many elements in that set? In that set, there will be only 11 elements, and all the 11 are the players. Then the next set. In the third example, the set is of points on a line. Okay, suppose I draw a line. Let AB be a line. Then can I count how many points are there on the line AB? No, I cannot. I cannot count the number of points on the line AB because there are so many points. That means infinite number of points that even I cannot count. Okay, so when I make a set of points on a line, then the number of elements will be infinite. So, infinite, that means we can't even count or we can't even list it. So, here you can see that in terms of number of elements a set has, there are three different types of set we can make. So let us define the different types of set and we will return to these examples after that. Generally, a set can be classified as two different types. Okay, that is, first one is finite set and the second one is infinite set. Okay, first one is finite set and the second one is infinite set. Let us first discuss what is a finite set. What is a finite set? Okay, a finite set is a set. A finite set is a set that is either empty or has definite number of elements. Okay, a finite set is a set that is either empty or has a definite number of elements. That means it has either no elements or it has some definite number of elements. Now let us take an example. Let A be a set. where X shows that X is a even natural number. X is a even natural number and X is less than equal to 100. Okay. Then in this set, how many elements are there? In this set, 50 elements are there. Because less than 100, there are 50 even numbers, even natural numbers. So, there are 50 elements in this set. So, we can say that this is finite set because 50 is a definite number. We can list them one by one. So, this is a finite set. We learned that there are definite number of elements in a finite set. Okay? That means there are so many possibilities of the number of elements in a set. Okay? And that number is known as cardinal number. Cardinal number means the number of elements, present in a set. Okay. Suppose a set is having one element, then cardinal number of that element is 1. Suppose a set is having 0 element, the cardinal number will be 0. So, in this case, the cardinal number of the finite set is 50. Okay? So, the number of elements present is known as cardinal number. Now, let us look at two special cases of finite set. Okay, the first one is empty set. Empty set or a void set or a null set, because all these three are having the same meaning, that is nothing is present. Okay, so we can define it as the set that has no elements is known as empty set. Okay, so now if I want to represent it, then how can I represent? I just put this symbol or give two bracket like this. This symbol is read as phi. Let A be a set where x such that x square is equal to minus 2, where x belongs to R. Square of any real number is always positive. Okay, always greater than equal to 0. Okay, but here we are given with x square is equal to minus 2. So there are no elements in this set such that its square is minus 2, because we know that every real number has square greater than equal to 0. So we can write this as a is equal to phi. So we can write it as a equal to phi. Okay, or like this, putting two brackets. Okay. Also, another example, let B be a set where x such that 5 less than x less than 6 and x belongs to natural number. The set of natural number is like 1, 2, 3, 4, 5, 6, 7, like that. Okay, that means there are no number between 5 and 6. So if the set B contains x such that 5 less than x less than 6 and x also belongs to natural number, then the set is empty or phi. Now another special case is singleton set. Single means one. That means this set has only one element. The set that has only one element. Okay, that is known as singleton set. Now let us take an example. Let A be a set where x such that x square equal to 9 and x belongs to natural number. We know that if x square is equal to 9, then x will be equal to minus 3 or plus 3. The only element possible for set A is plus 3 because minus 3 is not a natural number. So we can write it as A equal to 3. This is a singleton set. Okay. Now infinite set. Okay. Infinite set means the set that is not finite. Okay, the set that is not finite. That means any set except finite set is called infinite set. Like we have discussed earlier, one of the example is let A be a set where x such that x is a point on any line. Also, another example, B is a set where x such that x is a real number. So we know that there are so many real numbers like minus 1, minus 2, minus 3, 0, 1, 1.1, 1.2, like this. So many elements are there. So we cannot even count how many elements are there in the set of real numbers. So we can say that B is also a infinite set. Now let us return to the examples we have taken earlier. Now we can easily name the following sets. In the first case, the set of students who have failed in class 11 in 2021 will be 5, or we can write it as this. Okay, this is a empty set. And the second set is a finite set. Second set is a finite set because it has 11 number of elements, and the number of elements of a set is known as what? Cardinal number. So this set is a finite set with cardinal number 11. Okay. Now the last one. This set is, as we know, it is a infinite set because the number of elements present in this set is not finite. So this is infinite set. Now there is another concept of equal set and equivalent set. Equal set and equivalent set. Suppose I have three sets. Okay, A equal to what? 1, 2 and 3. B equal to 4, 5, 6 and C equal to 3, 1 and 2. Now compare the elements. In all the cases, the cardinal number is 3. That means the number of elements present on each set is 3. So the cardinal number of each set is the same. Now compare the elements. In the first case, the elements are 1, 2 and 3, and in the second case, in the set B, the elements are 4, 5 and 6. That means the elements are different to each other. Okay, in the case of set C, the elements are 3, 1, 2. We also have studied in the last class that the order of representation of elements does not matter. 3, 1, 2 or 1, 2, 3 or 1, 3, 2, all the things are the same. So C is equal to, we can write C equal to 1, 2, 3. That means this is equal to set A. we can say that set A is equal to set C because all the elements present in both the set are same. They are having the same cardinal number and the elements present in both the set are same to each other. That means any two sets are equal if their cardinal number is same. That means they have same number of elements and all the elements present in set A must be present in set C and all the elements present in set C must be present in set A. Okay. Now what do you mean by equivalent set? There is a small difference between equal set and equivalent set. If two sets have same cardinal number, that means they have the same number of elements, then we can say that they are equivalent. So in this case, A and B are equivalent, A and C are equivalent, B and C are also equivalent because all the three have the same number of elements. Okay. So in the equal set, the corresponding element of one set is equal to the second set, and also in this case the cardinal number of the two sets are the same. Okay, but in case of equivalent set, only the cardinal number have to be same. We don't think about what are the elements present in the sets. Okay, if two sets are equal, let set A and set C are equal, then we can represent it like A equal to C. Okay, but in case of equivalent set, we represent it like n of A equal to n of C. If two sets A and C are equivalent, then we can write it as n of A is equal to n of C. This means the cardinal number of elements present in set A is called cardinal number and it is represented by n A. Okay, that means the cardinal number is same. Another example of equivalent set. Let A be a set of all natural numbers that are even and less than equal to 10. Okay, less than equal to 10. And also let B be a set where x such that x is equal to 2n plus 1, where x is less than equal to 10 and x belongs to natural number. This can be also represented like this, and the second set can be like this. So now if we count the number of elements, in the first case there are 5 elements and in the second case also there are 5 elements. So we, by the definition of equivalent set, we can say that both the set A and B are equivalent. Now there is a question whether all equal sets are equivalent. Yes, this statement is true because in the equal set, the number of elements as well as the corresponding elements of the two sets must be same. I am leaving with 3 questions. You try to solve it and I will give the answer in the next class. Let A be a set where x such that x square equal to 25 and x belongs to natural number. Okay. B equal to x such that x square equal to 25 and x belongs to integer. And the last one is C where x such that x square belongs to real number. What you just have to do is you have to convert it in roster form and find out its cardinal number. Thanks for watching this video. Like and share it, and also to get latest update, subscribe it. Thank you.